research scholar from Harvard Knowledge University, Patna, and I welcome you to my presentation, whose topic is nano fertilizer from waste excel, sustainable production of calcium oxide nanoparticle for enhanced agriculture. First, out of the presentation is first we'll go with introduction section, synthesis method, characterization result, application, reference, and acknowledgement. Now, for the introduction section, we all know that waste Excel is basically common discarded natural waste arising from household and poultry farm industry. And for egg consumption annually in India, it is around 142.77 billion eggs per year. And for Bihar, it is 3.625 billion eggs per year. So this heavy consumption of egg is producing a million of tons of egg cells, which is causing different type of environmental problems like landfill accumulation and improper disposal. But in our research work, we are converting this waste excel into a calcium oxide nanoparticle, utilizing its full resource, and we are turning this waste into wealth for uh, application in agriculture, healthcare, and industrial application. Now we start with the synthesis process. First, we have collected waste excel from local market, and we have cleaned it with clean water and air dried for 1 day. And after that, we put in hot air oven for 110 degrees Celsius for half an hour. After that, we grinded it with the help of mixer and mix it with some herbal juice and produce calcium oxide nanoparticle by heating it for more than 1000 degrees Celsius at more than 3 hours. Now this is the XRD analysis, and in left figure you are seeing that the peak of calcium carbonate is arising at 29 degrees Celsius, which suggests the formation of calcium carbonate. But when we are heating our material for more than 1000 degrees Celsius for 3 hours, we can see that the peak is changing from 30 to 29 to 37, which indicate the formation of calcium oxide nanoparticle. And the average crystalline size for this calcium oxide nanoparticle was around 56 nanometer. Again we have gone through a same analysis where we can see that calcium oxide is agglomerated in our experiment. We suggest that calcium oxide is hygroscopic in nature, and when we are reducing particle to nano size, surface area to volume ratio increases, which increases the reactivity side, and that's why our calcium oxide nanoparticle is agglomerating. Now for the FTI analysis with this for our calculation of bond, means what kind of bond our calcium oxide nanoparticle has. So you can see different peaks are there, like at 713, at which indicates a CH3 metal group. For 873, it is carbon oxygen skeleton vibration. So different types of peaks present here in our sample, which comes from the presence of calcium oxide nanoparticle. Now we are applying this calcium oxide nanoparticle for different application in different types of plant as a fertilizer. The first experiment shows the role of calcium oxide nanoparticle in pumpkin plant. So in figure, when you see that on seeds were planted in two different pots, erupted from both the. But when we are seeing that the red one is treated group and the blue one is untreated group, but when there's as the time passes, you can clearly see the difference between growth of treated plant and untreated plant. The treated plants are more longer than the untreated. Got burned, means it got destroyed. But when we are applying calcium nanoparticle as passage of time, calcium oxide particle has helped our plant buried in red pot to regenerate faster. Okay, and this is the miracle of nanotechnology here, that one plant which is already burnt is growing faster than the untreated group. Now for the application calcium nanoparticle on ladyfinger plant, again at the last figure you can see that the with respect to time, the untreated plant have the disease on it, and the right plant was still intact and still free of disease, and it has more greeny leaves than the untreated groups, which also suggests that calcium oxide nanoparticle is antifungal and antibacterial, and also helping our plant to remain healthy. Now for the spinach plant, again you can see the difference between treated and untreated plant. And treated plants have some more healthier leaves, and they have more and more wider leaves, and in compared to treated plant, and the root and the length of plant was also very high as compared to untreated plant. Now for chili plants, you can see the difference that treated plants have the treated plant in blue pot have the uh, greeny leaves and they are healthy, and the untreated in red one plant is having the curly leaves and the leaves are turning into yellow and it is unhealthy right now. Now this is the difference between uh, treated and untreated tomato plant. When the right one is the treated plant, which are still very greeny, and the left one is your untreated plant. So you can see the difference between these two row of plants. Now these are my references, and these are my achievement and media coverage. I proposed this plan to the Industry Department Bihar, and they have agreed to pay me seed fund of 10 lakhs for my research work, and we are also starting a company over this. And this is my research team. Dr. Rakesh Kumar Singh, my guide. Dr. Abhay Kumar Singh also helping me in the project. The next one is me, and then Neeraj Kumar, he's sitting there, and Ajitendra Kumar. Thank you.
Thank you, Ashutosh. If from audience anyone have any questions? Oh, if okay, okay. Yes, please.
Yes, sir. Yes, sir. सर दो तीन चीजें सर, कॉन्टामिनेशन से भी बचा रहा है उसको, प्लस जैसे हम लोग डे वन पे जो हम लोग सीड बरी किए सॉइल में, तो हम लोग क्या देखते हैं जो रेट ऑफ जर्मिनेशन वो भी थोड़ा फास्ट हुआ है, और जो लेंथ जो आपका जो प्लांट ग्रो करने का है वो भी जिसमें ट्रीटेड है वो ज्यादा अच्छा ग्रो कर रहा है इन कंपेरिजन टू अनट्रीटेड, और ये भी चल ही रहा है सर हमारा भी ये। वो सर अभी नहीं है, अभी हम लोगों ने सिर्फ फिजिकल को देखा है, फिजिकल प्रॉपर्टीज को देख रहे हैं, इसके बाद सर फिर हम लोग केमिकल का एनालिसिस करेंगे। हाँ सर, ओके सर, जरूर सर, थैंक यू।
Thank you for your lecture, Ashutosh. Okay, now moving forward, we will be having our next oral presenter, Sumit Kumar. Please come on stage and present your work.
रिसर्च कौन सा है ये बताओ। ये है ये आगे जाएगा।
Good morning, all. My name is Sumit Kumar. I am from Patna University, presently working as assistant professor, Government Engineering College, Magadh. Basically, my topic is holes parameters by low energy air plus low ions on silicon ripples. What are holes? Basically, the holes. इसको हिलाइए तो काम नहीं करेगा।
थोड़ा आगे थोड़ा सा।
अच्छा, okay sir. So basically, what are holes? We are talking about the holes on the silicon wafers. Basically, the holes which are on the silicon wafers are of two types. That is, one thing is naturally, and the other is man-made. So moving on, basically, on the holes which are created by the ions beam. The ions beams which are generated by the ion source, like this is the ion source we have used, low energy broad beam ion source, 50 electron volt to 12 kilo electron volt, which is in collaboration with IUP Bhubaneswar. The basically definition comes here is a hole on the surface is a region which is surrounded by hills or flat surface at the perimeter boundary. It is generated by ripples waves created by ion beam radiations. The ion beam radiation is of fluence 10 to the power 17 argon ion per centimeter square we have taken on the surface by low to high ion fluences. A hole can be a number of depressions on the surface. It is varied by ion fluences considering at various angles of incidence taken at the surface normal. Below is the study of holes on SI substrate and its morphology. This is the dynamics. Here we see the pink. The pink represent the dynamics which are generated by the ion which when stuck on the silicon wafers. So these are the ripples generated are in like a curve form. And the second part is the original figure AFM instrumentation we have used. The images, that is the AFM morphographs, and we see clearly that the ripples are of a wavy nature type. Basically, these are the dynamics. We have the incident beam, which is inclined at an angle theta from the surface normal and generated by the ion beam source. This is the basically theory behind our investigation. That is, we have used the height of the band bending and where the the other parameters include the surface parameters, and we have used to study the surface morphology, and that are the surface ripples, roughness, measurement, ripple waves, and the other ripple wavelengths and other. These are the results coming from the investigation, that the variation of holes and area. The left figure represent the holes created by the ion beam source taken at different angle. We have we see that the angles are ranging from 35 degree to 75 degree. And we saw the curve is slowly bend at normalized value is given between 40 degree to 60 degree, 50 degree, 45 degree. And the right side curve represent the area of the holes that we have to use. Why we are using the area of the holes? Because we want to generate some 2D material layers on the silicon ripples. Because these ripples are used to create enhancement in the surface. Because we see in this dynamics, if the surface is flat, the area is small, and if the surface are of rippled nature, the area can be enhanced. So the area can be enhanced. That area can be used in various applications like gas sensors applications and corrosion inhibitors applications. Now the volume plot. We have also calculated the volume at different angles of incidence, and we see the green portion represent the maximum area coverage. So at an 45 degree angle is appropriate for the ion beam incidence. To the whole volumes. These are also the other results which have been calculated. Whole volume has been calculated because it is very important for the purpose of generation of 2D material by various synthesis route. Like we want to use it for chemical vapor deposition method because it is a cheapest method today. So that we can generate small layers or thin layers of a 2D material like MNS, alpha MNS, SNS2, SNS, or other 2D materials. These are the comparative chart of hill volumes and the maximum height for the holes. These are the result for the RMS roughness, that is the roughness of the surface, which is created by the ion beam source. we have taken for 100 intervals. This is the perimeter variation, means the whole perimeter. The whole perimeter is also important because lower the perimeter, the efficiency is reduced. So we want to enhance the perimeter so that the efficiency of the material can be used for various applications. So we see that after 50 incidence angle 45 degree to 60 degree, the perimeter has been enhanced greatly. These are the roughness average. We also want to know the surface morphology for the roughness, that more the roughness, more will be the affinity for the generation of 2D material layers. These are the result for the ripple wavelength. So it is not so of use, but we have also calculated it for our calculations. These are the original FM micrograph taken in account for the different angles, and the profile here we see in the second column. Also, there are the third column represent the holes and the 3D structures, and the fourth column represent the actual the center plot of the holes, where the holes are created on the surface. And the fifth one is the flooded region. Means what flooded region means if the radiation falls on it, what will be the capture area for the surface. Okay, sir. These are the 3D images of the surface. The third one is the 2D fast Fourier transform representation, and others are the spectrum images for the AFM micrograph. These are the calculations done on the data. These are the data we have used for the calculation. We have used the simulation software DSW. These are the data calculated on the basis of DSW. These are my references. Thank you for your attention.
Audience, if you have any question, you may ask. None. Thank you, Sumit, for your lecture.
Thank you.
Now I would like to call Neeraj Kumar to present his work. Please.
ठीक से देख के हाँ
To the oral participants, I would like to say that the time is 7 to 8 minutes. Please limit to your lecture to that time.
दो छोटा
इधर इसको पीछे करिए सर।
इसको अच्छा ऐसे ना लिया नहीं है
ये सर इसी में होगा सर।
है ये
आज तो उसमें कॉन्फ्रेंस सेट का है, ये वाला होगा सर। नहीं ये नहीं, पहले का हाँ ये
यही है ना जाएगा
ठीक। First of all, my greetings to all the dignitaries sitting front in the row and those who are sitting quite back. Myself, Neeraj Kumar, MTech student of Aryabhat Knowledge University, Patna. And during my MTech, I did some work related to the waste excel. And my research is calcium waste function nanomaterial from waste excel, a sustainable approach to converting waste to a technological grade nanomaterial. This is the introduction part, and next is introduction of excel. What is excel? And as we know, the excel is the highest. Excel has highest calcium calcium minerals in the cells, and it is abundantly available in the human body. it is a mineral that is essential part of the bones and teeth. And so far as in India, the consumption of egg is concerned, it is 142.77 billion eggs annual consumption, and this report is as per the 26th November 2024. And in Bihar, the egg consumption is 3.625 billion eggs annual consumptions. So that is why we decided to do some work on this, so that we are facing a huge environmental problem in this regard. So that is why we started to work in this area, as our guide suggested to work in. Next is some more detail about the egg cell, and here is the part of synthesis that I followed to convert the waste egg cell into a functional nanomaterial. Next is characterization that I did at the first level to understand the masses loss of the if calcination is done, then at what value it stays constant and no change takes place. Then next I did XRD just to know the crystal size of the crystal size of the particle and lattice strain. Next, I did the same to just to know the surface morphology of the particles. Next, even I calculated the direct band gap or indirect band gap just to know the material in which category it belongs to, because the focus of my research is to use this material as a semiconductor material, whether this egg cell can be used as a semiconductor material or as an insulator material. So that is why our study was focused on this subject. And so during this band gap study, I came to know the band gap, minimum band gap I just got is 3.6 electron volt, and maximum is 5.7. So it reflects this material is highly insulated, highly insulated, and it will be used as an insulator in the field of electrical and electronics. This is the P-loop technique, and with this method I came to know about the material, whether it is having ferro electric properties or not. Because of that, it can be used in electronics area as a memorable device or storing device. And this is my actually would-be component that about that our guide also said yesterday. This is the memristor. For that we have filed a patent, but about that we're not going to talk in much. So this device will be used for a storing device, and name is memristor. This is my team. I'm working under the Dr. Rakesh Kumar Singh, and my next as a co-guide is Dr. Abhay Kumar Aman, and next is me, myself, Neeraj, and next is Asutosh, who is sitting quite front of me, and one of my team member is Ajitendra, that is not available here. He's in the center. Next, thank you.
Thank you, Neeraj. You have done a pretty good job. Now, thank you. If anyone have any question, please ask. Yes, one question, please ask. Limit to one question, please. Okay.
कैल्शियम ऑक्साइड का जो नैनो पार्टिकल बनाने
Please switch on the mic.
कैल्शियम ऑक्साइड का जो नैनो पार्टिकल बनाने के लिए आपने जो मेथड यूज किया, कौन सा मेथड यूज किया है?
वो है calcination method by the burning process at different temperature for a different hour. Just I reduces the side and I came to the conclusion as a nanoparticle.
और इसका यूजेस किस चीज में करते हैं? बस एक आपने
Actually, I am not getting you. What are you saying? Your voice is not loud.
इसका टेक्नोलॉजी में और भी क्या क्या यूजेस है ये कैल्शियम ऑक्साइड नैनो पार्टिकल जो है?
My interest is just to use this material as a use this material in a electronics field.
Only electronics.
Only electronics. My focus is to, because I belong to the electronics area, that is why my research is whether this calcium oxide can be used as a electronics material or not. That's it.
Okay. Thank you.
Any question?
Thank you. Thank you very much.
Okay,
Thank you,
sir.
Neeraj.
Thank
Okay.
you.
Now I'd like to invite Sanchit Kumar to present his work, please. Again, limit to your talk to 7 and 8 minutes.
कौन सा ये फाइनल
PDF ना?
पीडीएफ खोले, क्या खोले बोलो, इसको खोलता है।
ठीक।
Good morning to everybody, especially to the head of the department and all the assistant professors and all the invited guests. A very warm welcome to all of you and very good morning. I am Sanchit Kumar, a research scholar of physics department, and my professor is Dr. Ankurva Sinha. And today I am going to present one of my work and a paper that I have recently published in ECS Journal. And my topic of the presentation is enhancement nickel ferrite property, the role of helium, galvanium, and lanthanum doping in for grain boundary restriction and leakage current reduction. This is the introduction part about the ferrites. Actually, ferrites are the materials, ceramic materials widely used in electronics, microwave, and power application. Nickel ferrite has an inverse spinel structure with unique magnetic and electrical properties. And in this study, I have doped multiple rare earth metals, galvanium, lanthanum, and helium in the nickel ferrite to enhance its properties like electrical properties and structural properties of nickel ferrite. Rare earth doping modifies the lattice introducing a strain and enhancing grain boundary effects, which I am going to talk in the next slides. Grain boundary in ferrites contribute to increase resistance and leakage current. Actually, in my application of ferrites, we have to increase the resistance for the better applications used in the ferrites. And this is the objective of the study. First of all, if we want to do something work, there should be objective and aim. Means what do you want to do with the ferrite or any material, what do you want to do with the doping. And in this paper, I have investigated the effect of multiple rare earth dope on the structure and electrical properties of nickel ferrite. I have used the multiple technique, XRD, XRF, spectrography, IV analysis for evaluating the different parameters. And I have evaluated how doping alters grain and grain boundary behavior, especially resistance and capacitance of the doped material. And then I have studied the leakage current behavior across different temperature and fields. And in the last, we have a conclusion that which dopants offer the best separation of leakage current and improve material performance. And I have used the Sol-Gel method for the synthesis material. And these are the, why do we use the Sol-Gel method for the material synthesis? Because of when we do the rare earth or any material doped in ferrites, there are multiple benefits of Sol-Gel method, because it will provide the high dielectric constant, low dielectric losses, reduce leakage current, and improvement of other electrical properties as per our requirement in the application, and alter grains and grain boundary behavior, especially resistance and capacitance. For the synthesis of material, I have used Sol-Gel autocombustion method for better control over homogeneity and particle size. And we have used nickel ferrite with 6H2O and rare earth dopant, helium, galvanium, and lanthanum oxide. We have used the citric acid as the fuel agent for the better homogeneity of the sample and better burning because it's an auto gel solution, then we have to auto ignite the sample, and that's why we have used the citric acid. And during the synthesis of material, we have adjusted the pH in the range of 6 for the brittle gel formation. Pure sample will be doped, will be labeled as NFO, and the sample which are doped with the rare earth are labeled as HNFO, GNFO, LNFO. And the main goal of synthesis is to achieve uniform composition with rare earth substitution. This is a flow chart in which I have tried to show that how I have prepared sample. First of all, I have measured all the sample in accurate weighting from the weighing machine, and then we have added we have stirred the sample for the 6 hour at 80-degree temperature, and after 6 hour we will notice that there is a grayish gel formation in the sample, and then after some time it gets auto combustion method, just its name like it auto combusts, and then it's going to the powder form, and after that we will grind the sample in the mortar form, and after that we will perform sintering at 800 temperature for 3 hours, and then we will get the final sample, and we will make it in the pallet and measure the different parameters. This is the XRD of my sample, and this confirms that inverse spinel structure in all sample with additional fix of rare earth impurity. As you can see that I have made the star marks there or asterisk marks for the additional phase or secondary phase that have appeared in my sample. Impurity phase formation increase with the dopant, just like we have selected the dopants with their ionic radius, and here the lanthanum has the maximum ionic radius. That's why it created the secondary phase. And this is the Williamson Hall plot through which we have calculated the strain and particle size of the sample. And pure sample, in the first figure you can get that there is a negative slope in the pure sample NFO, because there is no strain in the pure sample. But when we have doped the rare earth materials, we can see that there is a positive slope at which shows that there is some compression or some strain in the sample, which shows that there is some compression or strain in the rare earth doped sample. Increase in tensile strength with the larger dopant size indicates lattice distortion due to mismatch of ionic radius. And this is the XRF elementary confirmation. We have performed the XRF to confirm that the rare earth dopants are informally segregated in the sample, and that's why in the first figure you can see that there is no any additional phase.
चलिए ठीक है ये रिन्यूएशन नहीं कर पाए। हाँ अभी तो 50-60 ये रिन्यूएशन नहीं कर पाए। हाँ कौन सा सारे ही है नंबर ऑफ रिसर्च स्कॉलर हैं हाँ सारे रिसर्च स्कॉलर ये मान लो 50-60 रिसर्च स्कॉलर है होंगे 10-1 टीचर होंगे। देखिए इसको चेंज करना पड़ेगा स्विच अकाउंट करके हाँ ठीक है सर हाँ अब जो है यहाँ पर आपको अनाउंस करते हैं कि बीच में ना बच्चों के साथ वो इंटरेक्ट करेंगे हाँ। वो यूट्यूब से देख के इंटरेक्ट करेंगे नाउ ये है CHD का मेल
देखिए नेट चल रहा है हो जाएगा शायद
जस्ट
नहीं मैं अगर नेट लेना है तो हम देते हैं खाली इसको चार्ज में लगाना मैम लीजिए MKS के नाम से होगा
और उन्होंने तो ज्वाइन नहीं किया अभी तक
वो हो गया, देखिए तो नेटवर्क कितना कहाँ पे चला, दीदी वाला चला। जी सर। अब मेरा नहीं चाहिए, नहीं अभी तो छोटी है। ये देखो
कर लिया सिर्फ
नहीं किया,
कर रहे हो
कर लिया।
ठीक है करते हैं
अच्छा हाँ ठीक है। वो एक्चुअली उनके उसमें उसको स्विच करने से अभी इसका डिस्प्ले यहाँ पे इसका डिस्प्ले आएगा। हेलो कौन
हाँ वो कर रहे हैं
सर
क्या बात हो वो कह रहे हो रैप मतलब
मिल जाएगा 3 बजे के बाद।
नहीं
हाँ मिल जाएगा मैसेज चला जाएगा।
A message to the participants, please आप लोग सब जो है वैलिडेटरी सेशन में रहिए, और ये प्लीज कोर्स वर्क स्टूडेंट्स के लिए नहीं है, उनके लिए ये मैंडेटरी है।
सर्टिफिकेट डिस्ट्रीब्यूशन उसके बाद
हाँ, सर्टिफिकेट डिस्ट्रीब्यूशन उसके बाद होगा। अगेन आई रिपीट, कोर्स वर्क स्टूडेंट्स के लिए, और ये मैसेज बाकी जो स्टूडेंट्स बाहर है उनको भी बोल दो, अटेंडेंस लिया जाएगा, उस बेसिस पे सर्टिफिकेट डिस्ट्रीब्यूशन होगा कोर्स वर्क स्टूडेंट्स के लिए, उनको रहना मैंडेटरी है।
हाँ कर लिया ना
हाँ हाँ सही सर।
फोन पे ना बोलते
सर ने ज्वाइन कर लिया है मुझे लगता है, सस्टेनेबल एनर्जी एंड एनवायरनमेंट लैब।
फिर वो दिख क्यों नहीं रहे
तो दिख नहीं रहे।
बोलती हूँ मैं कैमरा ऑन करो कैमरा ऑफ है ना उनका
इसकी जगह पर एक वो सिंबल
कैमरा ऑन
हाँ घुरी दीजिए।
ये मेरी आवाज वहाँ कैसे गई है
हाँ यहाँ से जो भी बोलेंगे वो वहाँ पर सुनाई देगा। बैठो पहले बोले नीचे ताकि
Thank you so much, sir, for joining, and welcome to P.G. Department of Physics. Am I audible, sir?
प्रॉब्लम हो रहा है क्या?
नेट का इशू है कह रहे हैं 2% नेट चाहिए उसके बाद ही join।
तो क्या ओरल ओपी एक ओपी हो जाए हो ठीक हो 10 मिनट में हो।
So, due to some technical problem, we are going to have it after 10 minutes. And so now I would like to invite our next oral presenter, Hariram Kumar. Please do present your work.
ঠিক আছে, ওখানে ওই বলবে অবশ্যই বসে বসে বলবে না, খারাপ লাগে। হ্যাঁ হ্যাঁ ঠিক আছে, থ্যাংক ইউ। আচ্ছা আচ্ছা ঠিক
I request to please limit to your talk to 8 minutes.
नहीं लिया है क्या? ले लिया RAM टाइप पीपीटी दे दे या पीडीएफ दोनों। हाँ हम कर देंगे।
Good morning, everyone. I am Hare Ram Kumar, research scholar, Department of Physics, Patliputra University, Patna, doing PhD under the supervision of Dr. Vidhan Chandra Rai, retired professor, College of Commerce, Arts and Science, Patna. Today, I am here to present over the topic density functional analysis of electron correlation in quantum wire system. And my PhD topic is also density functional theory. So, main focus of our this project is on crucial role of electron correlation in determining the electronic structure and optical properties of the system, and also for controlling electron correlation effect in quantum wire with potential application in nano electronics and quantum informing processing. First of all, we will know about quantum wire. Quantum wire is also known as 1D nanostructure, means it is having 2D confinement of electron. Quantum wire systems exhibit strong confinement effect leading to a discretization of energy and enhanced electron-electron interaction. And understanding the behavior of electron in quantum wire is crucial for developing novel nanoelectronic devices. Our study focuses on main 3 points: ground state property and electronic structure, excitation spectra, and transport characteristics. First of all, we will discuss theoretical framework and computational methods. First method is density functional theory, which is of primary concern. It is based on Kohn-Sham formula, which is given by this equation you can see here, which is using external potential and Hartree potential and exchange correlation potential. What is meant by exchange correlation potential? To exactly describe the electron correlation effect in quantum wire, we use different correlation functions. First of all, we have used local density approximation. Local density approximation uses 2 types of energy, one related to exchange and another is related to correlation. Next one is generalization gradient approximation. It expands the exchange correlation, and if we compare between the two, local density approximation method is more accurate for real value. Third one is hybrid functional. Hybrid functional gives exact framework and uses the mixture of density functional and generalized gradient approximation. Next one is range separated functional. Range separated functional divide exchange correlation into short range and long range region of space. Basis set and pseudo potential. We use it to reduce the computational cost associated with treating the core electron and use non-conserving non-pseudo potentials for heavy elements. Lighter elements means which have low atomic mass, we use all electron basis set to calculate the accurate description of core valence electron. What are the computational details? Computational details are found using the open source software Quantum Espresso. We employed time-dependent density functional theory within linear response formalism. Transport properties were computed using the non-equilibrium green functional approach, means for the data which are not in equilibrium. Now we will move towards ground state properties and electronic structure. These are for semiconductor nanowires which are having 2D confinement, means 1D nanostructure. It exhibits direct band gap with calculated value of 1.52 electron volt, which is in good agreement with experimental measurement of 1.54 electron volt with error of 0.02 electron volt for gallium arsenide nanowire. Next, this is the calculated band gap and effective masses of gallium arsenide and indium arsenide nanowire using various exchange correlation function. Our result demonstrate the hybrid functional B3LYP and range separated functional CM B3LYP to provide most accurate description of electronic structure for both short range and long range correlation. Now we will move towards excitation spectra and optical property. Excitons in semiconductor nanowires are shown here, which are divided into various bands. E1, E2 and E3 points describes about the band and the region from starting point on x-axis, that is 1 to E1 point is subband 1 and E1 to E2 is subband 2, E2 to E3 is subband 3. It is divided into subbands. And these are also called peak. E1, E2, E3 are peak. Now the data for calculated exciton binding energy in mega electron volt for gallium arsenide and indium arsenide nanowire of different diameters. According to diameter, binding energies are mentioned for 3 nanometer, 5 nanometer, 7 and 10. Transport characteristics and device application. Quantum transport in semiconductor nanowires look like this, which is using non-equilibrium green function. Transport spectrum shows clear band gap region with zero transmission. Stepwise increase in transmission at higher energy corresponding to the onset of different subband. This is the calculated on-off current ratio and sub-threshold swings for gallium arsenide and field effect transmitters. Our result is demonstrate that hybrid and range separated functional predict higher on-off current ratio and lower sub-threshold swing compared to local and semi-local functionals. Last point, conclusion. We have performed a detailed density functional analysis of electron correlation effect in quantum wire system and also span a wide range of materials and phenomena including semiconductor nanowire, carbon nanotubes and atomic chains. But in this presentation, I am focusing on semiconductor nanowires. Main findings of our energies are ground state property and electronic structure. Second is excitation spectra and optical properties. Third one is transport characteristics and device application. Its effect in atomic chain such as resonance and anti-resonance are strongly influenced by electron correlation. Our result underscored the importance of using advanced exchange correlation functionals. These are the future research directions in the field in which this research project may be useful. Thank you.
Thank you, Mr. Hariram. If anyone has any question, please ask. Okay. Thank you. Okay. We have 3 more oral presenters left that will be hosted after the invited talk. Okay. Tanmay Deo, Adas Bharadwaj, and Dr. Khublal Shaw.
भारी क्या HDMI পোর্ট গুলো কি এতবার খোলা হ্যাঁ সেকেন্ড কাগজটা হয়ে গেছে थैंक यू क्या नाम है खूबलाल ना कौन सा है बताओ कौन सा एंड्रॉयड में हाँ ये खूबलाल ये वाला ना नहीं अभी नहीं रुको हाँ ऑनलाइन हो तो ऑनलाइन कनेक्ट नहीं हो रहा है तो कुछ अच्छा खूबलाल तुम्हारा मैंने डाल दिया है देख लो एक बार ये ना यहाँ पर देखो यही है ना तुम्हारा ठीक है मैंने पेस्ट कर लिया है तुम जाकर बैठो नहीं और जरूरत नहीं है কি অবস্থা ওদিক থেকে ফোন করে দেখছি এবং রিপোর্ট করছি যে জয়েন हो गए কিন্তু ভিডিওটা কি অবস্থা মানে গোটা ভারতের প্রবলেম থাকে এটা নয় শুধু এখানে
Thank you, sir. Am I audible to you, sir?
Yes.
Okay. Please allow me some time to introduce you to our audience. It is a pleasure and privilege to introduce our invited speaker today, Dr. Binoy Kumar, Assistant Professor in the Department of Physics at CCS Haryana Agricultural University, Hisar. Dr. Kumar brings over 10 years of teaching and research experience and has established a state-of-the-art research laboratory at his department, focusing on the synthesis and characterization of advanced materials. His core research areas include gas sensors for hazardous gas detection, supercapacitors for energy storage, and bio-nanoscience. He has already supervised 9 MSc and 2 PhD students with 10 more PhD scholars currently working under his guidance, reflecting his deep commitment to mentoring the next generation of researchers. Dr. Kumar is an active contributor to cutting-edge research with several impactful publications in reputed journals like Scientific Reports, Physica B, ACS Agricultural Science and Technology, Materials Letters, and more. His recent work includes the development of ultra-sensitive copper oxide gas sensors, natural resource-derived supercapacitors, and fly ash-based energy materials, demonstrating his keen interest in sustainability and innovation. With a strong presence in both experimental research and academic development, Dr. Kumar continues to make valuable contributions to material science and applied physics. Please join me in warmly welcoming Dr. Binoy Kumar to our virtual platform. Okay, sir. सर सॉरी फॉर इंटरप्शन सर, अगर आप इसको स्लाइड शो में कर दीजिए तो फुल स्क्रीन मोड पे दिख सकता है सर। ओके ओके थैंक यू सर।
Okay. So first of all, here in physics at of the university. So first of all, I thanks to the vice professor SP Answer Kumar sir, organizing secretary Dr. Emurani and Anko Sinha, and the rest are local organizing committee members. Really, this is a वीडियो का कट वाला सिग्नल young friends discuss things at this scenario here is where at this stage we stand and what we need, particularly what are the role of the materials to develop a sustainable society. So here from first slide I want to introduce to the smart materials of energy storage and gas sensing application a pathway for sustainable solution. At your side, is this visible at your side? Yeah, even there.
The connection is still very poor, sir. It is still not continuous presentation yet. Now it is visible. The first slide is visible, sir. But it's not being presented right now in the slide.
Still the internet issue.
जी सर, अभी भी इंटरनेट कुछ इशू हो रहा है। Don't know from which end. No sir, we are still unsure from which end it is the disturbance.
Okay, can we start now? In this.
Yes sir, the first slide is visible, sir.
Scrolling now? Slide is scrolling?
No sir, no sir. Only first slide. No, it's not moving, sir. Yeah. Yeah, sure, sir. Take your time, sir. Please. Well, it seems the problem continues. So we continue with the oral presentations. I would like to call Tanmay Dev. Please come and present your work. এটাকে বন্ধ করবো এখন? कहीं बुला रहे हैं सर इनको किसी और को बुला रहे हैं
तुम आओ ना यहाँ पर। ये तुम्हारा है तन्मय पीपीटी?
सर मेरे पेन ड्राइव में होगा सर।
मैंने वहाँ से ही लिया है।
नहीं सर वहाँ से नहीं लेना है, उसमें है अलग से बना हुआ।
ये है
इसमें कुछ हटाया होगा सर।
अच्छा ठीक है।
दैट इज गुड।
ये
इनका यहाँ प्रेजेंट करते हैं वो वहाँ से वॉइस होगा।
हाँ ठीक है ठीक है। पेन ड्राइव ये कहाँ पर है तुम्हारा?
वो सर
अच्छा देखो कौन सा है?
सुपर वाला है।
अच्छा पीडीएफ में है?
यस
पीडीएफ में थोड़ा सा प्रॉब्लम हो सकता है। ये वाला है?
नहीं सर
ये ना?
यस सर
ठीक है।
यस Good afternoon, everybody. This is Tanmay Dev, and today I'm going to speak on the topic different characterization techniques of material. And basically, if we are talking about the different characterization of materials, it means we have prepared a material. It means of what scale? It means of nanometer scales. And if we have prepared any material of that scale, we have to research, or we have to understand that what it is actually. Okay, so we have some techniques over that how we just can distinguish that what type of material we have prepared. So here we have there are several techniques to determine the characterization of materials. One more important thing is that why we need characterization of material. Actually, we need characterization of material because we want to measure or we want to determine a material on atomic or microscopic level. Another thing is that accurately measuring the physical and chemical properties of the material. So the thing is that before proceeding, we have to visualize some scales on which we use to understand any materials. The most important thing is that all the thing whatever is visible to us, all those things are in our visible range. And if we are talking about anything which is on the scale of nanomaterials, it means we need something special, a specific wave or a specific thing of a specific type of thing which will just interact with that space, interact with that surface. So here we will talk about different types of electromagnetic radiations, electromagnetic wave, which we just can say here. The first important thing is in the characterization methods, the first important thing is Bragg's law. I think that we all have heard about this Bragg's law. This is a very important or an interesting thing, that when anything the system is that when X-ray hits a crystal at the incident angle theta, they reflect with the same skirting angle and construct constructive interference occurs when the path difference equal to the whole number n of the wavelength. The resulting interference pattern is called Bragg's diffraction. Here I have one demonstration about the constructive and destructive interference. Here we just can see that we have a wave here, and we just can see here that if we are having a wave and it has trough and crest, as we know, and when it interfere, it may be in if it is in phase, it means it will construct it will have a constructive interference, and if the wave is not in phase, it means it is not uh, it will not form a constructive interference. So just here, if we will say here it is a wave, and if we will see here it is a crest and the trough, and if any wave is coming, if it will not interfere when if it will not in the same phase, then it will not interfere. It means it is a different it is a and this will constructive interference, and this one is destructive interference. So we just can say that if the wave is in phase, then it will form a constructive interference. So now if we will proceed, then we just can think that XRD, how we XRD of a material, we do XRD of a material, and we understand the physical properties and the physical structure of a material. So here it is a schematic diagram of XRD machine, and then the graph obtained by this machine. If the wave will come and it will interfere, it will construct, and it will form a constructive interference, then we will have a peak, and we just understand this is called the this is the spatial diagram, or we just can fingerprint of any material. So now, what are the advantages of XRD? Actually, it identifies crystal structure and grain orientation in material, and measures internal stress, crystalline area, size, shape, and atomic layer spacing, and so on. And disadvantage of XRD, X-ray diffraction, requires crystalline sample, atmosphere materials, and challenging in analyze, limited to surface analysis, and cannot provide bulk structure information, and so on. And another thing is scanning electron microscope. This is very important to understand that there, as I have told, that there are several things in which we just characterize the materials what we have prepared. So SEM is also one of them. And what it do? There's some calculations. It also works on the on different wavelengths. So we just can the action of electron beam stimulate emission of higher energy backscatter electron, and low energy secondary electron. It forms surface of the specimen. It means when we have prepared in a specimen, if we will fire an electron on that special prepared surface, then we will get something, and we just understand that specific data, and we just elaborate on that. Okay, now here we have two pictures: optical microscope image on nanofibers, and if we will go on SEM image, then we just can see that it is 4000x magnification. It means we just can visualize all that nanoscales materials on very clear way. With the application of all these, and we also do some a special characterization what a material shows on when we increase the temperature and lower the temperature. So all these techniques, DTA, DSC, and DGA, it means differential thermal analysis and differential scanning calorimetry and thermogravimetry analysis. All these things happens when we prepare our sample, and we just increase our temperature and decrease our temperature. We just understand that what the properties they are showing us. Okay, now if we will further proceed, we will show one most important thing, that is Raman spectroscopy. All we have heard about Raman sir, and what he has done a marvelous work in the field of science, in the field of actual physics. What he has said, he said that a laser shines on a sample causing scattered light, a small portion shifted wavelength, Raman scattering. Due to the molecular vibration, this provides a unique molecular fingerprint. This is a very important thing with which we just can understand any materials. And there are some limitations of this specific work. What is that? That is advantage of Raman spectroscopy is actually it is non-destructive technique and provides detailed molecular and structure information, and so on. And some disadvantages are fluorescence can interfere with the result, and expensive equipments and maintenance limited to the vibrational modes of the Raman shift, and so on. And that's all. Thank you so much.
Thank you, Tanmay. Anyone, any questions? Oh, yeah. Go ahead. Limit to one question.
Okay, yeah. Actually, scattered electron and the secondary electron. It means that when we fire a beam of electron on any sample, what happens? Actually, the electron interact with the interact with the surface of that specific specimen. And what happens? Some electron just get scattered, and some electron just observed by the detector. Some when it is just observed with the detector, it shows us the information about the surface of that. That's why this is the special actually the one of the differences between the backscattered electron and the second electron. Thank you.
Okay, thank you, Tanmay. Now I would like to invite Kublal Shaw to present his work, please.
यही है ना प्रॉब्लम जी यहाँ से आगे जाओगे यहाँ से नीचे ठीक है
Good morning, everywhere. Professor and respected organizing committee. Our title is Novel Approach to Designs and Developments of Hybrid Renewable Energy Using AI. Myself, Kublal Saw, Research Scholar, Department of Physics, BVU Hazaribagh, and my supervisor, Dr. Puran Saw, Assistant Professors, Departments of Physics, Sant Columbus College, Hazaribagh. My topic is novel approach. It means the era of climate change and big challenges of the world, because our world facing the problem of carbon emissions and dependency of fossil fuels, due to which our topics transitions of non-renewable energy to renewable energy. So our contributions towards the growing needs of hybrid renewable energy. First, resource optimizations enhance the reliability and cost effectiveness. All are the necessary parts of hybrid, which reduce the dependency on the non-renewable energy and fully depend on the renewable energy up to 2070. It is the target of Indian government in the Paris summit, and 50% of renewable energy target at the 2030. Sorry. Key features of hybrid system: integrations, optimizations, and the reliability. It means that integrations that combine the various renewable sources, and optimizations, it means the maximum energy output and the efficiency and depend on the renewable energy. Monitoring, real-time data, and the control of systems. Methodology I will use to complete my research work: AI-based framework, use MATLAB, AI-driven framework that integrate the predictive analysis, optimizing the algorithm, and real-time energy management tools such as the machine learning, example the regressions model, neural network, and the optimizations techniques, genetics, the algorithm, etc. It will help to framework will be the coded using the programming platform in the MATLAB to the facilitate the integrate with the HRES models. It means hybrid renewable energy systems implementations and the simulations. We will prepare the simulations of the AI framework using the real world synthesized data to test its application in the hybrid system. Simulations tool MATLAB Simulink will be used to replace the different scenario, including the various in the weather, load, demand, and the energy source ability. The outcome will be the validate the framework effectiveness to improving system performance. Future advantage: a promising horizons, reduce carbon footprints, lower emissions, if it depends on the renewable energy, already reduce the carbon footprint, increase the energy access, remote area benefit 24/7, technology advantage, improve the efficiency, economic growth, new job creation. It is 100% just like as solar job creations, and every sector of renewable energy like solar, wind already create and also create new job creation. Potential disadvantage challenging ahead. High initial cost. First, in the initial state, reality is that high initial cost, system complexity, grid integrations issue. This is the challenges ahead to face. The significance of hybrid systems, energy independence, and environmental sustainability and economic development are the key point and benefits of hybrid renewable energy. Why choose hybrid renewable energy? Because resilience, cost, and efficiency are the demands of today's world. Global energy capacity. In the global level, we are see there China, USA, Germany, after that India are the usables of renewable energy and dependency, but India have large skills and capacity to use the renewable energy. Cost reductions, solar PV at till that 2010, 89% reduce, and day by day dependency also reduce, and onward wind cost reduction since the 2010, 70% reduce, 50%, and battery storage. Key takeaway and the future steps. Hybrid renewable energy system offer the significant benefit. They enhance the reliability and the sustainability. Overcoming initial cost and the complexity is essential. Continue the innovation with drive the future adoption. Thank you, sir.
Thank you, Kublal. Now, if anyone has any questions. Okay. Moving forward, I would like to invite others to present his work. Okay, just wait. Okay, sure.
इनका है ये परवीन जी का है। अच्छा, आदर्श तुम्हारा है अभी ना?
वेट कर लो, आदर्श वेट कर लो। अच्छा,
नहीं आदर्श हो जाएगा, आ जाओ।
हाँ।
कौन सा है? परवीन ये वाला ना? इसको रख। ये है? ठीक है, ओके, ठीक है, ओके। कहाँ है आदर्श तो? कौन सा है? ये माय प्रेजेंटेशन। ये पैक करके दूसरा वाला है, इसमें लैटिस है बस। अच्छा, कौन सा है दूसरा वाला बताओ? इसके ऊपर वाला क्रिस्टल स्ट्रक्चर एंड द रोल। अच्छा, ठीक है।
Good afternoon, all. Hi, I am Adarsh Bhardwaj, a PhD coursework student, and thank you, sir, ma'am, and all friends giving me the chance on this platform. This is my first oral presentation. I'm a little nervous, but at the end, everything will go in a better way. Today, I am representing the oral presentation on crystal structures and their role in material science. As we all know, for living, all need water, meal, material we use in everyday life in every aspect. Crystals in very important Yes, sir, yes, sir. In very important aspects, like it has many roles. Our like in nanotechnology. So at first, I'm defining the crystal structures. Like we have many topics. Like we have we are have crystal structure which is made up of atoms and have crystal lattice is made of points. So in this crystal is very important for our life in every places. Like we use different types of materials in nanotechnology, like medicines, robotic things. In every places we use the crystals. Like what is crystals? So the atoms and molecules which are arranged in the fixed manner, and they have many types like single crystals, polycrystalline solids, and non-crystalline solids. So in single crystals and polycrystalline solids, they have different structures, but in the fixed manner. Like single crystals have some examples like quartz, alum, etc. And polycrystalline solids, metals, like it contains metals. And if we talk about non-crystalline solids, we have amorphous like glass, rubber, etc. So, on the basis of an atom or group associated with lattice points, we have identical composition, arrangements, and orientations, which is called bases. And we have different types of crystal structures, which is hexagonal, triclinic, trigonal, tetragonal, orthorhombic, monoclinic, and cubic. So, if we talk about the lattice, lattice helps in the structure formations, and we have the different types of lattices. Like we have the simple cubic or primitive lattices, body-centered cubic lattices, face-centered cubic lattices, and hexagonal closed back. If we talk about the simple lattices, atoms are arranged on the corners. Like we have 8 corners, and it is totally based on the 8 corners. And if we talk about the BCC, we have basically atoms packed on the edges and on the center of the solids. And if we talk about the face centered cubics, we have all atoms arranged on the corners, and one basically is one atoms basically arranged on center of every sides. And if we talk about the hexagonal closed pack, here is the all sides, which is totally 19 in numbers. So, importance of lattice in physics is like it helps in atomic bond arrangements and strength, electronic configurations, and conductive properties, thermal and mechanical behaviors. Like we have many techniques to use the crystal structures in our life. So if we talk about the unit cell, a unit cell is basically the point of, it is just like a smallest geometrical unit which is repeated in a space indefinitely, generates the space lattice, which carries a full descriptions of entire lattice. In this, all atoms are arranged on the edges of the cell. And if we talk about the lattice parameters, we have different angles and on the basis of size, like we have sides A, B, C, and where the angle is projecting alpha, beta, and gamma. So if we talk about the alpha angles, it is totally opposite to the side A, and if we talk about the beta angle, it is totally opposite to the side B. And if you talk about the angle C, it is totally opposite to the angle. Talk about the gamma, it is totally opposite to the angle C. So if we talk about the unit cells, we have cubic unit cells, tetragonic unit cells, orthorhombics, and hexagonal, rhombohedral, monoclinic, and triclinics. They give the structures of any atoms or any crystal structures. So if we talk about what is the difference between SC, like a simple cubic, body center cubic cells, and face center cubic cells, we have, like you can see in the diagram, there is the presentation, like atoms are presented on the edges, and in the BCC, which is in the center, and in the FCC, there's all are on the centers of the edges. And now we have the differences between NaCl and CaCl in the crystal structures. Like if we talk about the sodium chloride, it has FCC, and if we talk about the cesium chloride, we have a BCC structures. And in these things, in both these things, the coordinate numbers is like, if we talk about the NaCl's coordinate number is 66, and if we talk about the coordinate number of CaCl, it is 8:8. So now, thank you so much. This is my representation on crystal structures. Thank you.
Thank you, others. Now, I would like to call Praveen Kumar as our invited speaker is waiting, so please limit to your talk to 5 minutes, okay? Thank you.
कौन सा था?
Good afternoon, everyone. My topic is a short review on transition metal doped copper sulfide thin film as sensor and solar applications. My abstract is, in recent days, need of energy helps us for development of industrial and technological applications. The thin films technology is the heart of solid state technology, and it could be taken in nano range due to its application in solar energy, optoelectronic devices, and photoconductor, etc. Metal chalcogenides are studied in the form of thin film and is considered as a heart of semiconductors due to application it's in photovoltaic cell, solar cells, optoelectronics devices, etc. 1B26 say group focused on chalcogenides, etc. family, which lies so many materials such as cadmium sulfide, cadmium telluride, sulfur sulfide, and zinc oxide, etc. Because it can be helpful for fabrication of solar cells together with the optoelectronic devices. The copper sulfide is the member of 1B26 group element, p-type semiconducting materials, and has energy band gap जो है इसका 2.5 electron volt है. And the transition metal doped copper sulfide thin films band gap varies from 1.26 electron volt to 2.6 electron volt, which are applicable for solar cells, sensors, photocatalysis, lithium, chargeable batteries, etc. The effect of transition element over copper sulfide structural, morphological, and optical properties have been reviewed. The majority of the human existence is significantly dependent on energy. We need power for cooling, lighting, for transportation, cooking, and heating. We utilize fuels, and consuming fuels, fossil fuels, has an especially harmful effect on wildlife, plants, and human beings. And non-renewable energy resources are limited and have an impact. People worldwide need to be aware of renewable energy sources. Due to limitations of energy transmission for solar energy is a specific type of renewable energy resources that has been through crucial research and is fully utilized. The sun is the large gaseous globe and emits solar radiations, which are significant source of energy resulting from the fusion of hydrogen nuclei. And the sun producing about 6.4 into 10 to the power 7 Weber per meter square, of which, assuming no solar absorption in the space, about 1370 Weber per meter square is incident on Earth atmosphere, and roughly 980 Weber per meter square of the power density reaches the Earth surface. And the organic or inorganic compounds with electrical conductivities that fall between insulator and metals are known as semiconductor materials. And the semiconductor materials may be chosen for the construction of electronic devices due to differences in their electrical properties. The semiconductors are often divided into two groups. The first is compound semiconductor and the second is elemental semiconductor. Compound semiconductor, that means extrinsic, and the elemental, that means intrinsic semiconductor. The periodic table states that group 4 contains elemental semiconductor materials such as silicon and germanium, and the compound semiconductor materials are created by combining elements from third to fourth. The researchers are focused on the semiconductor thin films due to its various applications in science and technology. And the thin films are usually divided into two multiple classes based on the used coating materials, including metallic and dielectric coating. And the metal chalcogenides thin films are used in the various applications. The copper sulfide compounds are well known, and it can be found in two forms, that is copper rich phase and copper poor phase. And these are the stable phases for room temperature, that is orthorhombic anilite, monoclinic roxybite, and cubic digenite, monoclinical digerite, and monoclinic charcoalites in the copper rich region, and the hexagonal covalite in the sulfur rich region. And these are the The copper sulfide materials are beneficial for optoelectron devices, well as good solar radiation absorption properties because of their low energy band gap and tunability depending on their different phase, copper sulfide ratio, and morphology. Doping type and the sulfur containing ligands play key role for particular luminescence, emission, and enhanced efficiency. When the size of the nanocrystal is smaller than the Bohr excitation radius of the material, they exhibit properties which are size dependent and distinct from the bulk. Such a material is a very promising one in the electronics, data storage, energy storage, catalysis, and sensors. Thank you.
Thank you, Mr. Praveen Kumar. Any questions? Okay, fine. Thank you. Thank you, sir. So now we will have a final attempt to connect with Dr. Vinay Kumar. कहाँ join हो गए? Am I audible, sir? Yeah. So, yes. Sir, you are visible and audible, sir. Yeah. Yes, sir. Yes. Your first slide. No. Yes. Yes, sir. Okay. Thank you, sir. No, sir. It's only for us to have you and also us.
This is fortunate for me to impact the young minds at this stage, and particularly the opinion that sometimes recent advancement in research. So today the topic is to be smart matrix for energy storage and sensing application. A part of process solution. So I will start my slides after time. Including various colleges here. We have focus on agriculture, and I joined here we can explore better income because you can at land level slide change
हम फोन करेंगे तो वो फोन पे बोलेंगे तो सबका सुनेगा
to our society. So now we must be getting to components here. We can connect a few areas to the society, industry, how to cycle ourselves. So here, the main theme of our department here is working areas to firstly office management, how to convert cycle with how to convert valuable products. Another one, the issue here is the energy. We have the idea about we are sitting on electrical vehicle due to the issue of the environment or road things involved in development society and parts here have the environmental issue. So we are shifting to the electrical vehicles, electrical advanced. Another one, we are developing the gas sensor detection due to the economic condition and burning of fossil fuels. Gas is released there, but still we have the talent to detect the gases where we are using. And some kind of things we are seeing, particularly in the human seasons, where dams function. So we think that how the society like
है ना बोल रहे हैं कुछ और बोल रहे हैं स्लाइड कुछ और है
this is a introduction of our department slide. Just we just slide our department of physics. We have only two members, actually, myself, and we have that study here to learn things in a what I would discuss about the officer of the department. We have the things and we are trying to better to develop the things whatever our society. So some instrument we have here. For energy storage, we have a potential thermostat to discuss things for this project. Application, another one we have also the gas sensor system to detect the hazardous gases. We are developing the smart material, advanced material to make the things in the manner and to meet the requirement. So here, doing so firstly, we all know that I'm audible.
Yes, sir, you are audible.
इसमें थोड़ा आप वाइब्रेशन की करते रहे जिससे कनेक्ट है
Okay, sir, okay. Sure.
because I'm on slide now, not on the video call.
No issue, sir. We will let you know. We will let you know if any time you are not audible. We will let you know, sir. No issue, sir.
Okay. So here, while we are discussing about the things where why we need energy, so everyone know that in India particularly, day by day, we are growing. Particularly the population is increasing in an exponential manner here. In 2010 and 2025, in 2010 the population was 6 million and today 20 million. And if this exponential manner, population will be improved in order to be in the years. So this is a challenge to build the things according to the increase the population. So in every sector, we need the energy and how to feed the energy to everyone. In our industry sector, in our auto sector, we need the energy and how to feed to everyone. This is the challenge because we have resources to meet us. And secondly, we have resources and these are related to our environment. So what is the solution? So we can see what are the and especially we have solar system, we can convert the energy to the solar. But we have a challenge if the solar is energy storage. So how to store the energy still in that we have the issue of the power and the storage. So this can be overcome due to the sustainable energy sources. And in the parallel manner, due to the burning of fossil fuels and keep the energy demand, like in the coal and natural gases, biomass. So these are related to the environment. also, and how the gases, particularly hazardous gases, what are the level in our environment, and after that we can protect ourselves and we can do the things like to overcome the issues. Everyone have idea and in everyone and every week India and this we hear about this from supply contracts enter in the Magadh and there are gases and they roast them. Everyone have this idea. You know that in our environment, yes, so we need to know that sensor to so here you can see that there are most and least polluted countries directly and you can compare with their argument. And such kind of things, everyone have the idea about the air quality system, and particularly in the industry and the September to November, and they are these related to each other. We know the things that we are related to each other. Farmers are doing the things, industry are doing the things, but in manner, we are not thinking what will be the solutions, what kind of things we need to develop this. And in today, what is the scenario of our globe? Everyone have an idea, but and we just need some more to this system. Okay. We still we design this library system for audience who enter or carry the research in teaching students. First we think what we want to do and why we want to do. The issue their minds we are doing, but we are in a don't-care system. Like we don't and everyone हमें क्या है हमें क्या करनी है especially the Gen Z generation now ठीक है उनका पढ़ी है इससे काम नहीं चल रहा है just you can see the what is the situation today our I believe this in 2025 a lot of carbon in our environment हमें क्या करें that in 2030 so इस तरह का होगा so next in 50 and after that years I believe carbon carbon generation is I believe so they are 48 and we see this pet bottle water in the pet bottle. That's what is started. And that's over balance of that. I think हम लोग में कर रहे हो ठीक है ये प्रकृति की देन को इसको लेके जा रहे हैं ये भी उस टाइम पे काम होना हम किस डायरेक्शन में जा रहे हैं और still we are living in India we have a lot of resources of water what we are doing in 1965 this we started this tank water or the start in the past last but after that the government shifted on the plastic water tank water when protect this bottle plastic also harmful for our environment. Another thing, just we are discussing about the carbon. Another thing I will is the packed oxygen. We can survive with the packed water. Because we need the water in our water system. We need water for 5 times of we survive in a smooth way. But about the oxygen packed of the survive. This is the alarming situation for all of us. When we going, what we are discussing, you have the idea. Everyone aware the system. Our habits are have of the good practices. So, environment. The issue how to sustain the environment, how to sustain the society, how we can do the this is the for all of us. If we think about that, how we can work on that things. So here we can try to do the things to do the smart. For any sustainable development, what is important? We need environmental protection, we need the social progress, and we can say that our society is sustainable. So, what are the need? We need efficient energy. We need clean environment. So firstly, we can go for clean environment. Firstly, how to check our environment, we don't know how to check the environment of the electricity. And second one, how to overcome this challenge of the energy storage. So people are doing in this direction. We are not only in India and from the world we are in this direction to detect the message in a low level at PDB level also. And to convert the energy and store the energy in a better manner, I believe what are the challenges with the so what we can do and what we are the solution. Like we everyone know that we have a renewable energy sources, but challenge here is the storage of energy. So here, super telescope can work on this carrying the storage of energy because have the capacity of television to get the that's one to detect the various gases. We can detect the gas with the gas sensor. Firstly, to need the things we require the smart meter. Using smart meter, we can do the things we can develop the sustain. So we need smart materials, and everyone knows that. I believe this era, all we know that about the nanomaterial. Nanomaterial have specific property using in nanomaterial. We can overcome these challenges. We can develop a sustainable society. Using the things like we have smartphone, we have smart watch. This means that if anyone is smart, this means that have specific properties. If a man is looking smart, first we think by the characteristic. Another one, what he did, looking smart. So he made such kind of smart mechanisms. Okay, this can simplify the analysis. So we know that about the nanomaterials and what are the properties any material have a size equal to 100 nanometer. These are the nanomaterials. And this nanomaterial, particular also we have like gel like material and more than the wall. They are material, the material can help to aligning on the wall. Okay. Another the natural things we can see in the road, like in the this is the road we can things we can see and here we can see the many colors. Look at the optical property of that. So here in the nanomaterial has a specific characteristic. Everyone have an idea if you are going from one to the since that surface to volume is increasing. That surface to volume is increasing. This is that surface increases. And to develop the things, to develop the technology, we require such kind of material. Have the size is small, but have the characteristic is very good. Like surface area is large and the size is small, so we can develop the small device. So nanomaterial have the surface area high in comparison to what from these graphs we have here called material and nanomaterial. This is material is almost here. We developed this almost in the farming, our lab, and we captured here the surface area of bulk material by 11 point something, and after that we all built the material and we found here surface area 124. So while we are discussing, because smart material is nanomaterial and nanomaterial have a specific property, using these specific properties, we can do the things particularly in the energy sectors and gas sensors. In the optical property, everyone have an idea, and the size is increasing, the colors, you can see the change here from the yellowish to red. This is that and red here in the so in the continuation, nanomaterial have chemical and electrical property also. Particularly, all know that if any material is semiconducting, but if we decrease the size, the material will go the middle capacitance will increase, and we can develop any semiconducting material in that field. So here we can see here using the nanotechnology, we can develop sustainable society. We are using the nanomaterial in the clean water, using the solar energy, agriculture system, food safety, and medical health sector. People are using the nanomaterial. They material due to their characteristic. Uh, we are developing our society. Particularly the post issue, other things, property, especially but if we discuss here about the medical health sector, if we have any nanomaterial, this is that have the surface body, and in the medical sector, for that, if we are taking any bulky medicine have the size larger distance that any can achieve medicine we require to take. But if we are using the nanomaterial there, this is that we are required a room from what we take. This is that if we are taking any medicine in the less amount, so this is that this will be less effective. Particularly, and the medicine is still one medicine can say likely this will be good for our human health only. They have a more things to degrade our body. So this is the history of nanotechnology. Firstly, everyone hear about in 1857, Michael Faraday. He saw the equilibrium solution of four nanoparticles, but at time this was noted down there. But this was first time saw in the equilibrium solution of four nanoparticles. After in the continuation manner in 1890, in 1959, everyone had idea. Richard Feynman discussed about the theoretic quantity of the room at the bottom. And in 1974, this was documented, note down by Toguchi, define the term of nanotechnology. And after that, we are doing the things by in a better way. And in 2004, the material is truly material, with the group on the truly material. The truly material is the graphene discovery, and this was discovered by the P.G. and P.A. Now, the material was discovered in 2004. And this truly material is a wonderful material. The beauty of this material is like this layer structure, technical properties, high mechanical properties, too high in comparison to the bulky material, have the graphene is the conducting nature, and graphene have graphene oxide and reduced graphene oxide. So we can develop the semiconductor material also in the category of today. So here the types of nanomaterials. I think the research scholars here. So, can I talk to anyone? Who is online here now? Can I interact with the audience? Can I interact with the audience?
Yes, sir. Yes, sir.
Anyone here?
Yes, sir. I'm here, sir. It's just that I
Yes, sir. Just I want to interaction with the students because of, they started their career in the research. They have about the classification of nanomaterials. They have idea or not. I want to be interaction with.
Yes, sir. Students are here. I assure you that the full house is there. I'm just flipping the camera or laptop towards the audience.
Is it visible, sir?
Yes, ma'am. Yes, it's visible. This is general question. I want to interact with the audience and have you any idea about the classification of nanomaterials? If any nanomaterial like the quantum dot, what kind of dimension?
So, yes. Yes, sir. Am I visible and audible to you, sir?
Classification of nanomaterials.
Yes, sir. Yes,
Okay.
sir.
Now I would like to go to some of our students. Okay, fine. Introduce yourself first, sir, and then.
Good morning, sir. My name is Ashutosh, PhD research scholar from Army Knowledge University, Patna. अच्छा classification बटे
Yes, sir.
yes sir.
Yes, so here is the question is have you idea about the classification of nanomaterials?
Yes sir.
Okay, so can you define any zero dimension material?
Yes the quantum dot is a zero dimensional material in which electrons are confined in all
आवाज
different
नहीं आ रही
directions.
Can you define zero dimension
The
material?
dimensions electrons are confined in all the three directions x y z. Electrons are confined in all the directions x y z.
What is your clear to me? Was he not clear to me?
Actually, okay, sir,
General question where
he was trying to say that what did say again?
सर जो जीरो डायमेंशन मटेरियल होता है ना उसका जो इलेक्ट्रॉन का एनवायरनमेंट थ्री डायरेक्शंस में होता है एक्स वाई जेड डायरेक्शन में उसके
if anyone is research, so please go through the classification of nanomaterials. What are the zero dimension? What are one dimension? What are two dimension? And what are three dimension?
Sir, his answer was, I'm just conveying his answer. Am I audible to you, sir?
Yeah.
His answer was the for zero dimension system. There is three dimensional confinement for the electrons. That is what I think you are giving the answer. Yes, that is what you are saying.
Very good. Very good. This is the correct answer. We need the confinement of the three dimension in the nano. And particularly we are discussing about the quantum dot. Have the size up to your 10 nanometers. We have such certain type of material creating quantum dot, other quantum dot. So this classification is required to very clear. Like you can ask what are our 0, 1D, 2D and 3D material and why they are specific, why they are different in properties. Using this material, we can develop a sustained society because this material can be used in various applications, not particularly singular. So here we are discussing about the 2D material and we just heard about the graphene in 2004 and this is the 2D layered material and particularly graphene is zero gap material like the particularly the conducting material but the rest of the graphene oxide and graphene oxide have semiconductor nature have and we can change the properties of the material during in synthesis process. One was temperature was the optimization is our job. Another one material is the 2D material is material MOS2. MOS2 is I think the trendy material in these days people are using and MOS2 have many stages. You can see in the slide. This MOS2 have 1 stage, 2 stage, and 3 stage. Using these stages, we can use this material in various applications. And particularly, this material has a layer structure, but we can design the several morphology of this material using the synthesis technique. And particularly, here we want to use like we require the high surface area, so we require the high temperature to synthesize the material. The beauty of this material is we can design several kind of structure in this material. We have the floor of light system, we have the layered structure, we have sheet like structure, we can design in the synthesis. So here the job here is we discuss about the material, we discuss about the nanomaterials, we discuss about the very required sustainable development. But how to synthesize the material, this is the job here. Particularly, people are doing this direction and have various approaches. We have two approaches here, top-down approach and bottom-up approach. And we should know about the top-down approach and our bottom-up approach. Here the top-down approach we can use to develop the material modeling approach. We can use the thermal evaporation system. We can use the inspection system. We can use the laser ablation system. But these techniques, these instrumentation is mostly like this, but is mostly laser ablation. So if you want to do the things most effective, so we can opt the bottom-up approach. Bottom-up approach is here is we can design the material using the CVD, we
we can design the material using the hydrothermal method, we can using the method, we can open the method, Fulton method, and co-precipitation method. And using here, I mentioned the hydrothermal method. In the scenario, this is very primary. Using this hydrothermal method, you can design several kinds of structure at a minimal cost. At a minimal cost, you can design a several kind of structure, floor like you can design a layer type structure, you can roll like structure, you can develop like this is the layer like structure. You can design the several kind of structures using the hydrothermal method because we are yes sir, yes sir. Yes.
Sorry to interrupt you, sir, but please confine within 20 minutes sir, due to time limitation.
Okay, no issue, ma'am. But no issue है मेरे simple सी है. I have no issue to concluding with students. I'm discussing with the students before who started their career in research. So he or she should know about these things. What we can, what our requirement is. Okay, ma'am. Okay, sir. So to characterize to characterize any nanomaterial. So firstly, we require the XRD to confirm the material is particularly sure the material is prepared or not. So we require the XRD to confirm the structural information or material is particularly like this is correct or not. Because every material has a particular peak. If you go to a particular peak, this material is confirmed, otherwise not. Yes.
बस चीन स्टूडेंट का पुस्तक है वो भी जाए
आर्टिकल है तो चल जाएगा ना ये चलता नहीं है जीवन जैसे हम इन्होंने है हमारी
एक एक करके जाना
हमें स्ट्रक्चरल इंफॉर्मेशन के लिए नेचुरल इंफॉर्मेशन के लिए इनिशियली एक्सआरडी पे जाना चाहिए स्टूडेंट शुड गो एंड कंफर्म आवर मटेरियल इज synthesis or not. Another one for surface morphology, mentioned many times here, what kind of you can design the several kind of structure. So we can confirm the what kind of structure using the efficiency we can do. Another one, optical properties, like I discussed band gap, and if you are using material, and your material is having the certain nature, so you confirm the material has band gap, you use the visible. Another one, the bonding of the material, we can we need the FTIR, using the bonding, zero bond, double O bond, OSP, present can or not, we require the IR. Another one is, this is the important technique, maybe student have this idea, but if anyone is working in the field of gas sensor, yeah, energy storage, so we require the specific surface area, we require the material porous, microporous, microporous, so this is the need. So we need the band. Using a band, we can confirm the material have a specific surface area, this one. We can confirm the material have the such kind of core there, using mesocore, microcore, yeah, macro. So we can confirm and we can calculate the things using the band. Another question is to audience, if you want to confirm, we are discussing like 2D material here, and 2D material have MOS2. This particular subject there or not, and from XRD, confirm is being available, particularly this is 225 or not, how we can confirm? And your idea how we can confirm this particularly 225 or not?
Yes, sir. It took some time for me to come to the laptop. That's why. I am going to convey your message to the students. Please say one more time, sir.
Okay, just I want to instruct the students that they have the idea how we can confirm the chemical composition of the material, and particularly what technique we need.
Okay, Jyoti, one of our students, can you answer to the question that was asked by our invited speaker? How can you confirm the composition of an element of a material? If you have any idea, Jyoti.
XRD is not confirm the chemical composition. XRD just define about the material. This material like B or O agent here, but particularly this B2O or not, we can't confirm within that file.
Her another answer was EDAX. Her another answer was EDAX from scanning electron microscopy. Yes, sir.
We can define the composition there, but particularly this is O5 or not, this is O4 or O3 maybe. So let me conclude here. We can use
one more answer we have from audience, please.
Sir, spectroscopy से composition पता कैसे?
His answer was atomic absorption spectroscopy, from which we can confirm the elemental analysis.
Okay, so we can do this one with the yes. So this one I wonder about that because the students should know about how to what that and put the things and we can confirm the material is or not. We can define the orbital using that.
Okay.
So here how to utilize this material? Firstly, we prepare the material using the program method. Another one, we characterize the material with confirmation of the material and the properties of the material. How we can apply, we are discussing about the supercapacitor. So firstly, we should know about that. What is that? Supercapacitor is also known as ultra-capacitor electrochemical capacitors. Advanced electrochemical energy storage devices to store energy through physical charge rather than storing the chemical reaction like that. So here we have the idea about the capacitor, but capacitor have the power efficiency high, but energy density is low. In the case of the battery have the energy density is high, but power efficiency is low. So we require such kind of device.
Sir, just clarity for once, sir. Am I audible to you, sir?
Yes, sir. Yes, sir.
If possible, sir, please conclude within 5 minutes. We have genuine time constraints, and that's why I'm okay. Thank you.
So to discuss the supercapacitors, actually we need the electrochemical workstation, and firstly we require to prepare the electrode to discuss the things, and material have maybe the EDLC and pseudo, and if any material is pseudo, then can fulfill our requirement like what we need the energy density and power efficiency. So in our lab, we firstly whatever we discuss how to pulse to nano, we can define the property and how to overcome the challenges. This is that like depend on the properties we can take almost two and the polymer almost two, and here the surface area is higher in pulsation work and electrochemical performance is was better in the polymer most, and this paper, this was published in the Aeronautics and Energy. Another one will synthesize a kind of structure, likely the floor-like structure, and using the optimization of the solvent, because in any reaction, solvent is also important. So this has the water solvent has a better efficiency in terms of the electrochemical. The specific resistance was 428 square per gram, and the work published in the recently in vacuum. So the here another material is the 2D material is the RGO, and we synthesize the sheet-like structure, and the structure have what the surface area is 172. But I already discussed if surface area is high, then this means that this will be the better for our application. So here this work is published in the material letter last year. So these material is really important. These material has a beauty because they have due to their characteristics. But here I am discussing about the optimization is our job. What was your temperature when you synthesize? What was your time interval when you synthesize? And after that, what was your solvent? What solvent you used in the synthesis? So several parameters are important to design any material to work as a better application like this. In the similar fashion, we discuss the material in gas sensing application. And in gas sensing application particularly, we are developing the chemical assisted gas sensor. Chemical assisted gas sensor means that the changing the resistance, and on behalf of the change the resistance, the material adsorb and desorb the gases, and you can confirm the what kind of gas was present, and likely the what was the level of the gas here, and we detect in our lab at PPB level. We are developing here NO2 and aqueous gas using this gas sensor system. We have this gas sensor system, and several kind of parameters required to discuss the gas sensor. And here we designed a 2D material MOS2 for the NO2 detection, and here at temperature 100 degrees centigrade, operating temperature 100 degrees centigrade, we reported here 24% response of MOS2 cloud-like structure for the detection of the NO2 gas as 100 centigrade. Another one material is design MOS2. We just change the we just change the reaction temperature, and this same material MOS2 can be used to detect the H2S gas, and we design this material, and the material here MOS2 is detect the H2S gas with the response of 14%. So such kind of work we are developing the gas sensor and supercapacitor in our lab, and using these materials, these smart materials, we can design a sustainable society. Using the supercapacitor here, we can use the supercapacitor in the radar technology and military, smart technology, electrical vehicle, and portable electronics. This is the need of this time. And another one, the development of gas sensor can be used to develop smart cities, smart industries, smart homes, smart healthcare. Thank you, audience, to give your valuable time, and thanks to organizing team to give the impact young minds impact. And here, thanks a lot, Dr. Special thanks to Dr. Renurani to invite me to impact with young minds in this event at their university. Yeah, thank you.
Thank you so much, sir. And we are truly apologetic to you because we hurried a little at the end of the lecture. But I assure you, you may not get the vibe of the lecture in person, but we have full house as an audience, sir, and I hope students have listened to you well and good, because those who are going to opt experimental research in future, they will be honored and privileged if they get any kind of connections with your team, and that statement is not only true for them, for us also, sir, too. So we will be happy to have you in person in future. Also, we will be so honored and glad if you can, by some, you can give some exposure to our students in future as well. Having said that, we cannot, for the constraints of the mode, we cannot felicitate you. Okay, sir. Yes, sir.
I mentioned in my electronic form that you can see a review for the students if anyone have any question.
Okay.
And any student want to work with me, have any difficulty to do work in his or her sector, so they can contact me. Another one, not particularly for your student, if any your faculty from your institute
Yes,
want
sir.
to
Yes, sir.
work collaboratively, so welcome all of you.
Okay. Thank you, sir. Thank you so much.
Thank you so much, sir.
Okay, ma'am. Can I leave now?
Yes, sir. You may leave, sir, now.
Oh, thank you.
Thank you.
Okay, thank you.
मुझे लगता है कि पोस्टर डायरेक्टली बाद ही होता है।
अच्छा, ठीक है।
पोस्टर लग गए हैं, वैलिडिटी के बाद राउंड लगा लेंगे।